Alright guys, welcome back. We're going to be solving another question from chapter 4 of Hibbeler textbook, and in this question we have this 1500 pounds boom AB and 200 pound cage BCD over here, and we have a man that has a weight of 175 pounds, and we have three different center of gravity for each of these three. So we have G1 for the beam AB, we have G2 for the cage BCD, and we have over here G3, the center of gravity for the man. And we need to determine the resultant of the moment produced by the weight at point A here. So as always, we're gonna start with the free body diagram, but before that, please make sure to subscribe to the channel and share this content with your friend that might find this helpful. And let's get started. So we have this beam AB here that we know it makes the angle of 75 degrees. So we have the first center of gravity in here, G1, and we know the force is the weight of the boom AB, which we know is 1500. And over here we have the cage BCD, which we know the force at point G2. So here we have G1, this will be G2, and we have 200 pounds at this point, and we have also the weight of the man, let's call it G3, and we know the weight of the man is 175. So we have three different forces that are applying in this system, and we need to find a moment about point A, and we have the information for all the distances. I'm gonna show it in red. So we know from here to here is 2.5 feet, here to here 1.75 feet, and also we have 10 feet for here and 20. So now we are good to go to use our 2D shortcut that we have for finding the moment. For those of you guys that haven't watched that video, I'm gonna put the link in the description below. So feel free to check that out to learn how to use that 2D shortcut that we have for finding the moment in two-dimensional questions. So basically all we need is just to find the force in x and y direction and the vertical distance from the point A in here to the line of action of the force. So let's start with the first one. So all we need to find is the moment of the resultant, which is all of these three forces about point A, and as always we call counterclockwise positive. Let's start with the 1500 force, and I'm gonna show it in different color, then we can see it easier. So what we need to do is to find the moment of 1500, and as we can see, this will be the direction of the moment about point A, which is clockwise, so we have a negative sign, and the force is 1500 and it's already in x and y direction if we call our x and y like this. So the force is pretty much in the y direction, so we don't need to do anything about that. But for the distance, so as I mentioned, we go with the vertical distance to the line of action of the force. This is the line of action for the 1500 force, and the vertical distance is this distance from here to here, which if we look at this triangle will be 10 times cosine of 75. That's pretty much everything for this force, and we can move on to the second one. I'm gonna show it in the light green for the other force. So same basics. We basically have this time the 200-pound force. Again, we see that the moment about point A is clockwise, so another negative sign. 200 times the distance would be again we have this line of action over here, and the distance that we have is, if we look at this right triangle, we have this distance here plus here, Here we know it's 2.5, and for finding that one we basically have the hypotenuse, which is 10 plus 20 times cosine of 75. So the distance will be 30 times cosine of 75 degrees plus 2.5 feet. And this would be the second component. The last component would be the let's show it with a different color. Let's go with dark green. So it's the moment of 175. Again, we have a clockwise moment, so another negative sign in here. The force is 175, and the line of action would be here, and the distance is from point A to here, which is the same distance that we had in the previous part. So we have 30 cosine of 75 plus 2.5 plus this little distance in here, which we know is 1.75. And this would be all of the moments that we have. And if we calculate this and add all these together, we'll have minus 37.75 pound-foot. And as we know, one kip is 1,000 pounds. So basically for finding this in kip, we need to divide this by 1,000. And if we do that, we'll get 8.04 if we round up the final answer. So we'll get kip, foot, and this negative sign in here shows the direction, which was clockwise. And this would be the final answer for this question. Again, please make sure to subscribe to the channel, and feel free to share this content with your friends. If you have any specific question or a specific problem from each of the 3 textbooks that we're covering in this channel, feel free to leave it in the comments section, and I'll try to cover it in the next videos. You guys take care. I'll see you in the next one.